discuss parallel processing. Parallel processing means a process or an operator operating parallelly on different systems. To show parallel processing, at least we need two inputs. Let us discuss parallel processing on realize on a single qubit state. So for a single qubit system, single qubit system, the circuit, the initial state 0, and first Hadamard taking as operator or function which gives 0 plus 1 divided by root 2. Next, we are taking a parallel processor as parallel processor X and this changes it 0 plus 1 divided by root 2 to 1 plus 0 divided by root 2. As we know, X get changes 0 from 0 to 1 and 1 to 0, right? Then the function x fx will get form, and x belongs to 0 and 1, right? This fx equals to capital X, and this x0 equals to 1 and x1 equals to 0, right? Now applying this function like this function here. So it becomes 1 x as x belongs to first 0, then so 1 plus 0, right, divided by root 2 equals to this fx equals to fx equals to x. So f1 equals to 1 equals to 0. So 1 0 plus 0 1 divided by root 2. This is the realization of parallel processing on single qubit system. Now realization of parallel processing on 2 qubit system. So for 2 qubit system, we are taking the initial state 0 0 as it is a 2 qubit system. Then Hadamard H1 H2, it gives 0 0 plus 0 1 plus 1 0 and plus 1 1 divided by 2. As it is a 2 qubit system, it gives a result of four possible outcome or 4 possible states. This is 1 2 3 and 4 possible states, and the function summation of x fx. X belongs to 0 0 0 1 1 0 and 1 1, and this fx equals to c naught that is control node from 1 to 2, first qubit to second qubit. Now applying this function in this steps, so it becomes we can write it here, summation over x fx fx equals to c naught from 1 qubit to second qubit, first qubit to second qubit, and x belongs to 0 0 0 1 1 0 and 1 1, right? Now applying this, so it gives 0 0 f 0 0 plus 0 1 f 0 1 plus 1 0 f 1 0 plus 1 1 f 1 1 divided by 2, right? Now this f from 1 to 2, this fx is c naught 1 from first qubit to second qubit, this and this, so this 0 0 this is remains same, this is also remains same as 0 on the control qubit, and the target remains same, so 0 0 0 0 plus 0 1 0 1 plus 1 0, and it flips to 1. It is, as you know, from the c naught so 1 1, as you know, control node from first qubit to second qubit, if first qubit the state having 0, then it flips the target qubit, and if it don't flip or don't change the target qubit, and if we take 1 as control qubit as control state, right? So control qubit it flips or changes from the second qubit or target qubit, 1 1 1 0 divided by 2. This is the realization of parallel processing on a 2-qubit system. Similarly, we can realize parallel processing on different qubit systems, 4-qubit systems, and the formula we know 2 to the power n, and n is the number of qubit. So that's all about parallel processing on different qubit systems. Thank you.